Hi, my name is Ron Lohman. I'm here with my colleague Gary Ruggles, and today we're going to talk about AI chipsets, specifically the host to AI accelerator connectivity. What can you tell us about different trends you're seeing with respect to the interface IP used to connect these?
Well, there's a lot of interesting standards that apply to this. PCI Express is one. CCIX is another that some people may have heard of, and probably the newest one is CXL.
And you mentioned some brand new technologies, C6 and CXL. Those are more recent, and what were the purpose of those?
Yeah, great. So C6 kind of leapfrogged PCI Express 4.0 because it went from 16 gig to 25 gig. It added in cache coherency, which was pretty cool. It added in a lot of capability to do mesh architectures and potentially switching and peer-to-peer transfers and things. And then it went on more recently, just in October, to go to C6 1.1 and bump the speed up to 32 gig.
So neural networks require heterogeneous compute, so I can see where cache coherency could be of value. What interfaces are supporting that type of capabilities?
Great question. So PCIe was not known for cache coherency, so that's why C6 was introduced. Some others came out, but the big ones are C6 and CXL.
And can you talk about maybe some of the advantages of CXL versus C6? What's the difference?
Sure. So C6 came out first, and it originally came out at 25 gigabit transfers per second. Sounds impressive until PCIe 5 came out at 32. So it's faster, added cache coherency. CXL is the most recent one.
Okay, so we have some very high bandwidths that we're being able to support with these new technologies. Do these technologies support switches? I see switches in a lot of configurations with respect to AI accelerators.
So certainly PCI Express does. It supported switches for a long time, both dedicated switch chips as well as embedded switch technologies, and there's various hierarchies. You can have many switches in a very complex topology. C6 in theory can support the same thing because it's built on that PCI Express protocol, and the difference is it has two virtual channels, one for coherent traffic and one for conventional non-coherent traffic or PCIe type traffic.
Another big bottleneck with respect to neural networks and AI accelerators is around memory. Do either one of them tackle memory?
So all of them can address memory, but the only one of the three that I mentioned that specifically targets memory is CXL. So CXL defines three protocols. One of them is actually named CXL.mem because it's the memory protocol that allows a host to take all these attached devices like accelerators and then have their memory mapped right into the host address space.
Okay. What types of reads and writes can take place with any of these host to accelerator technologies? Is there something special about one versus the other, or are they very similar?
So all of them can support memory transactions for sure. PCI Express supports them. C6 adds some C6 optimized packets, which can be a little more efficient if they're doing memory transactions. But in both those cases, they're not specifically targeted for memory. CXL actually brings in this .mem protocol, which is specifically intended to allow hosts to take advantage of attached memory on devices, and that memory gets mapped into the host memory space, and it's great for things like storage class memory or other kinds of byte addressable memory.
Okay, so 5G and AI acceleration is introducing lower latencies. Can you expand a little bit more about the latency capabilities of the different technologies?
Yeah, so latency is relative, of course. PCI Express is not known to be a super low latency standard. It does allow this hierarchy of switches and real complex topologies. C6 came along, again introducing the cache coherency, but because it adds a transaction layer on top of PCI Express, it actually makes the latency a little bit worse. What really has fantastic latency is CXL. So CXL has stripped off kind of all this overhead. It's pushed the ARB-MUX that they use to combine flits at a really low level, so it all happens very quickly, and the latency as a result is the best that you can get in these kind of standards.
Okay, great. So how does Synopsys play a role in these technologies?
So we're offering complete solutions for all three of those that I mentioned. So PCIe 5.0, we've already got a large number of customers. For C6, we've had a C6 1.0 solution, which was that 25 gig I first mentioned for quite some time. We've got customers for that. We've also got a complete solution now that supports C6 1.1 at 32 gig, which is pretty much brand new. And then we were the first vendor to announce in September a complete solution for CXL as well, which is CXL 1.1, the latest version.
these interfaces are tackling high bandwidth, they're tackling low latency, they're tackling cache coherency. It sounds like we have a lot of different solutions to help with host to AI acceleration type connectivity.
Absolutely.
So I want to say thank you for your expertise today, and appreciate you sharing that with us.
Great. It was great talking to you about it.
Likewise.
Thank you.